أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Today we will be talking about nanotechnology and environment. This lecture is a part of the lecture series regarding the course of nanophysics and technology, having the course code of PHY445. This is almost the last lecture of this course, and in this lecture we will wind up the course along with the nanotechnology relationship with the health and the development of new technologies so that it is environmental friendly. Basically, we want to review the concept of nanotechnology where it has several definitions. So, with many definitions for nanotechnology, the NNI, which is actually called as Nanotechnology National Nanotechnology Initiative, call it nanotechnology, which has given it the name of nanotechnology only, if it involves all of the following. The first thing is that research and technology development at the atomic level, molecular level, or macromolecular levels in the length scale of approximately 1 to 100 nanometer. So I mean, if we are dealing with the particles that may be atoms, molecular or macromolecular in the range of 1 to 100 nanometers, so it comes in the scope of nanotechnology. The second thing is that creating and using structure, devices and systems that have novel property and functions because of their small and or intermediate size. We already understood that coming toward the decreasing size, the property of the material greatly changes. So if we are dealing or we are studying the properties of the materials at nano level, and the properties are a bit different from the bulk level, so this study is also devoted to the study of nanotechnology. And the third part is that ability to control or manipulate the systems on the atomic level. So that is also related. If we are engineering atoms or molecules at atomic level is actually the angstrom level, or maybe it turns about less than even greater than a bit uh, the nanometer. So if we are dealing at atomic level or nanometer level with the atoms or molecules, so that is also the study, or we are engineering the atoms or molecules, arranging a different orientation or in different ways. So that is actually the engineering of materials, and that also comes in the scope of nanotechnology. So looking toward the size spectrum of environmental particles, we have different environmental particles that are involved, just like we have fluorines and nanotubes. It comes in the range of 0.1 to 10 nanometer. We have some nanoscale contaminants in water and air. That is also a fact. So its sizes are just like if we have H2O, that is 0.2 nanometer, hemoglobin is 7 nanometer, and viruses, the size of the virus is 10 to 100 nanometer, and microbial and cells and protozoa is just like it's increasing order. So we have different, just like reverse osmosis, ultrafiltration, microfiltration, and conventional process for that. So that is actually the part of that. So we have filtration, that is actually the process of clarification or clearing that material or that sample from the hazardous things, is actually that process include. So what are these material properties, or I mean what type of nanomaterial we can use for the environmental cleanup, or we can use the material for dealing with the health issues, or dealing with the type of degradation of inorganic materials, So what type of material we are using and what is the size range of that. We have nanostructure that includes the clusters, nanocrystal or quantum dots. So its range is in the 1 to 10 nanometer, and the example material of such are the insulator, semiconductor, metal and magnetic materials. So other nanoparticles whose size is ranges from 1 to 100 nanometers are ceramic oxide or buckyballs. We have nanowires in the diameter of 1 to 100 nanometers, which include metals, semiconductor oxides, sulfides, and nitrides. And nanotubes that are especially the carbon nanotubes. Its size is also 1 to 100 nanometer and it includes fluorines and layer chalcogenides. How we can adjust properties of nanomaterial, as I already discussed in the first slide, that we are engineering the properties of material by arranging or by adjusting the structure of material, and structure and properties are closely related with each other. So if we want to tailor the property of the material, we need to we need to deal with the structural problems, or we need to uh, manipulate or engineer the structure so that we can improve the property. If we consider the catalytic properties, so we have better catalytic efficiency through higher surface to volume ratio. We need to increase the surface to volume ratio. For electrical properties, we need to increase electrical conductivity in ceramics and magnetic nanocomposites, and that is increase electrical resistance in metals. For magnetic property, we have increased magnetic corrosivity up to a critical grain size or the superconducting behavior. Similarly, in mechanical properties, we have improved hardness and toughness of metals and alloys, and that is actually affect the ductility and superplasticity of the ceramics material. If you want to deal with the optical properties, we need to have spectral shift or optical absorption and fluorescence properties that increase or affect the quantum efficiency of semiconductor crystals. And for spherical, we have increased selectivity for this particular case. In case of biological properties, we need to deal with the increased permeability through biological barriers, that is the membranes, blood brains and barriers, and the other things, that is the improved biocompatibility. So characterizing nanomaterials, how we can characterize the nanomaterial means what type of material, means the origin of nanomaterial of different nanomaterial. Just like we have nanocapsules, so nanocapsules are naturally obtained and it is unintentionally released and manufactured. We have some quantum dots, and quantum dots are made from the chemical composition of these nanomaterials is just like metals or metal oxide, polymers or carbons, semiconductors. We have also the quantum dot of semiconductors, biomolecules or compounds. This is actually, the circle shows the different type of possible nanostructure, and the other shows the properties of this material. This is actually the characterization of materials of characterization parameters of nanoparticulate materials. So we have nanocapsules, ultrafine aerosols, particulate materials are actually all these materials, quantum dots, nanotubes and nanoparticles. So these have some special property, it is made from the it have a particular origin, its chemical composition, aggregate state, surface modification, dispersion in, and the shapes, particular shapes. So we can get different morphology, just like spheres, needles, platelets and tubes. So similarly, the aggregation state is might be different, just like we have single particle or maybe aggregates, or we have agglomerates, depending on the arrangement of the particles. So dispersion is also possible, just like you have gases and liquids, maybe solids. In maybe solid we have matrix materials. So that is in case of surface modification, if we need to modify the surface, so maybe untreated surfaces, that is actually as obtained in the production process, or maybe we need to coat the sample for particular characterization, that is for conjugate or polymeric films. Maybe we need to core or shell particles, that is spheres or capsules, to cover it. Some of the actually the application of nanotechnology is vast, but here we can list some of the application of nanotechnology in different fields of life, including the automotive industry, the electronic industry, chemical industry, construction, engineering, and medicine. So especially in automatic industry we can use in lightweight construction objects, and in painting, in catalyst, and in electronic industries is specially used in data memory, just like MRM or GMR, and in display it is also used. In construction, nanotechnology is also widely utilized, while in medicine and engineering it is broadly used for improving the properties of materials. Looking or extending the application of nanotechnology, it is also used in textile, fabrics at non-owns. It is used in food and drinks, and energy, because we need renewable sources of energy coming from the solar cells or batteries or capacitors. And the same nanotechnology is used in households that have ceramic coating for iron, and it is also used in cosmetics for the sun protection, lipsticks and skin creams, and toothpaste as well. Nanotechnology has useful application in sports and outdoor as well, and it is also used for different type of production which are comfortable and have useful properties for the its application in sports and outdoors. Uh, how the things are revolutionized from the nano level, I mean the nanotechnology, because it's greatly improved the property of the material with and at the same time with greatly improvement in the property of the material, there is abrupt reduction in the size of the material. So that is quite interesting, and that is why it has revolutionized the different industries. As we mentioned, the different industries starting from the engineering, medicine and health, and different fields of life. So we have other application of nanotechnology as well, as in sensors and in treatment, as well as in remediations. So it is widely used for the different type of application, and nowadays in different almost all aspects of life we can use nanotechnology, and all the relevant I means the instrument, that is actually the digital instrument, or maybe some that is based on the nanotechnology or the circuit. We are preparing the material for that at nano levels, so that is directly or indirectly used in different application. In sensor, definitely we can observe it directly, but in medical treatment, or maybe in we can indirectly observe, because most of the diagnostic tools are made from the high level develop nanotechnology instrument that give broad diagnosis of the interior systems. So in remediation, it is also used for cleaning the contaminated sites with problems brought up by the prior technologies and past practices, because normally we are dealing with the environmental problems because along with the limited energy sources of energy, the environmental pollution is also a great challenge for the whole world, and that is why the world is trying to develop technology that is environmental friendly, and that is not harmful for the environment, because it will make maybe the if the if the environmental pollution gradually increases, so it will make life on this planet very difficult. So that is why the advanced technologies, the scientists in advanced technology are greatly concentrating on the environmental issue of each prepared instrument, so that there is no harmful byproducts from that. So that is also useful, and see that the technology is greatly changed, and we are not even concentrating on the efficiency of the machines, but we are also concentrating on the on its effect when it is utilized in a particular environment. So the remediation is also important for that. So we have green manufacturing, that is actually called as the green manufacturing and green technology. The green technology is often used because we have both aspects involved: use of environmental friendly starting materials and solvents for the improved catalyst, and that is normally used for that. So we need to develop the green technology so that the byproducts obtained from any type of chemical reaction or any electronic circuit or any type of engine operations, there is no byproduct that is harmful for the environment. In other, so that maybe we can create such a way, in such a way that the byproducts are useful for the environment. So for that purpose we have green energy. The green energy is actually the nano products such as solar and fuel cells could lead to a commercially viable alternative clean energy sources, and that particular clean energy sources is also called as a green energy. So energy saving via lightweight composites or embedded system, and the most important issue is the development of green energy. We can utilize the green energy to run the systems without creating some harmful effect to the environment. We have nano geochemistry that is also used for that, and Implica toxicity, that is the essential issues, and we have in transport we are using that green energy, because most of the conventional engine that were used, it's a byproduct. When it is running the engine, it is not useful for the, it is harmful for the surrounding or for the environment. So that is why technology is improved to move towards the hybrid systems, or maybe to completely electrical system where the byproducts are not harmful to the environment. So that's the implication of that. So for the nanotechnology, National Nanotechnology Initiative Grand Challenge for research in nanotechnology, we have nanostructure material by design, that is actually manufacturing at the nanoscale, and that have the chemical, biological and radiological explosive detection and protection. So we have nanoscale instrumentation and metrology, that is the nanoelectronics, photonics and magnetics. It is usually used in healthcare, therapeutics and diagnostics, and so it's efficient energy conversion and storage, that is also a part of that, and nanotechnology is used for that. We have microcraft and robotics, that is the more advanced form of nanotechnology, and the nanoscale process for environmental improvement. So that is the most important things. How we can modify all the above 8 technologies so that it have positive impact on the environment. Nah, I mean, so that not and maybe it have not positive, but it should not have negative impact on the environment. So it means so that it cannot the new technology that is designed using the nanotechnology should not be harmful for the surrounding. So that is the most important things. So I mean, it should not be harmful for the surrounding. So we have great training for that. And the environment is the application or measurement of the environment in the environment is like that, you see. And we have application for sustainable material and resource, which is particularly used. And similarly we have application for sustainable processes, for natural and global processes, and for the application in health and environmental safety. We need to develop high throughput or multi-analytic toxicological methodologies with focus on mechanism and fundamental science of particle toxicity, and access to well characterized nanomaterial for conducting research. So that is also useful for that. And finally, we need to wind up the lecture with the other grand challenges and related issues in the for the nanotechnologies are the metrology, energy, and the nomenclature classification of particular type of nanotechnology. So this is something what we want to uh, discuss, that what is nanotechnology for and why it's so useful and what is its effect on the environment and its surrounding. So this is almost the uh, uh, end of discussion regarding this course. So thank you very much uh, for watching this video.